Welcome to Q&A Wire.
Okay, we need to draw trans 1-chloro-2-methylcyclohexane. So I'm just going to draw the overhead view of this first. And we've got chlorine on the one, and this is trans, so let's just make this a wedge. And then on the two, we have a methylcyclohexane, so if it's a wedge to chlorine and this is trans, then it's got to be a dash to the methyl. Now I'll move into drawing the chair conformer and its ring-flipped conformer. Okay. And I'll call this carbon 1 and 2. And I like to call the upper right-hand carbon carbon 1, and the go around clockwise, adding substituents from there. And in this particular conformer, if chlorine is the higher of the two substituents, that means it's axial up, whereas the hydrogen substituent will be equatorial and down relative to it, and the methyl is going to be the lower of the two, which means it'll be axial down, and the hydrogen will be equatorial up and to the right. All right, and to do the ring flip conformer of this, you start with parallel lines that are slanted in the opposite direction. And I like to call this lower right-hand carbon carbon 1 after I've done a ring flip, which makes this carbon 2. I get that 2 out of the way though, because it gets in the way of the axial substituents. I'll put it right there. Okay, now we know that we're going to, at carbon 1, have an axial substituent that will point down and an equatorial substituent that will point up and to the right. And we know chlorine should be the higher of the two, and hydrogen should be the lower of the two. And for carbon 2, we'll know we'll have an axial up and an equatorial down and to the right. And hydrogen should be the higher of the two, and methyl the lower of the two. All right. Now, what are they asking us? The spatial relationship between the hydrogen on the C1 and C2 hydrogen in the most stable chair conformation is. So we've got to decide what the most stable chair conformation is. Well, clearly it's the one that does not have any bulky axial substituents, right? Putting methyl axial and chlorine axial is not energetically favorable. It's not stable. Okay, so now it's telling us to look down the 1,2 carbon bond and determine the spatial relationship between the hydrogens. Okay, so I'll just draw a Newman projection from this angle here. All right, so I would appear to have a hydrogen that is straight down. I'm going to have a chlorine that's up and to the left. And then this is up and to the right is the rest of the ring. Oops, hydrogen is straight down. All right. And for the back carbon, I would have a hydrogen that's straight up. I would have a methyl that's down and to the left. And I would have the connection to the ring down and to the right. And the question is, select the spatial relationship between the hydrogen on the C1 and C2 in the most stable chair conformation. Are they gauche eclipse bonds with a 0-degree dihedral angle, eclipse bonds with a 120-degree dihedral angle, or anti. These are anti, right? They're just across each other from the Newman projection. I suppose it wouldn't have been too hard to just eyeball that, right? This one's going axial up, and it's one bond away. This hydrogen's going axial down. That's pretty default for anti. Right? All right, let's continue. Spatial relationship between the hydrogen and C1 and hydrogen and C2 in the least stable chair conformation. Okay, so now we're talking about this, which may be a little harder to see, but honestly, it's not that bad. The hydrogen in front is up and to the right, and the hydrogen in back is down and to the right, right? I can just continue drawing these in. We've got methyl, and this is the ring. And in the back, the chlorine's going straight up, and the ring is going down and to the left. That's looking down. I happen to look down this one from C2 to C1. It's just slightly easier to look at for me. But now we see that there's 60 degrees between hydrogens. And this is what would be called a gauche interaction. Let's see. Gauche eclipsed bonds with 0 dihedral angle, eclipsed bonds with 120 degree dihedral angle, or angle anti. Oh, I see. The options are gauche, eclipsed with 0 dihedral, eclipsed with 120 degree, or dihedral with eclipsed with 120 degree dihedral, or anti. And so the answer would just be gauche. This is like the definition of gauche interaction. Okay.